So today we're going to be taking notes for translating to real world problems, which is under the New York State Standards topic of modeling expressions and equations. So as a result of this lesson, you should be able to use academic language to identify the terms and constant term of a mathematical statement, relate parts of an equation and expression to real world contexts, and you should be able to model real-world problems as mathematical expressions and equations. So the standards are listed on the left here, and we've also included the next gen standard, and the general approach in doing these problems is to 1, read and understand the problem, 2, underline keywords focusing on variables and operations, 3, convert the keywords to mathematical notation, 4, write the final expression or equation, and in some cases, if it's in an equation, to solve for the problem, and 5, to check for the reasonableness of the solution. So the big ideas you need to keep in mind is that the important skills in mathematics involve recognizing and using academic vocabulary to 1, communicate the structure of mathematics, and 2, relate parts of mathematical equations and expressions to real-world contexts. So let's refresh your memory of what an equation is. It's an equation, or an equation consists of 2 expressions connected by an equal sign. The equal sign indicates that both expressions have the same equal value. The 2 expressions in an equation are typically called the left expression and the right expression. An expression is a mathematical statement or phrase consisting of 1 or more terms. Terms are the building blocks of expressions, similar to the way that letters are the building blocks of words. An expression will always be either a monomial or a polynomial. So the first set of problems, which are numbers 1 through 4, are going to be related to expressions. We're going to set up an expression. So the first question states, to watch a varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $3 and the cost of a student ticket is $1.50. If the number of adult tickets sold is represented by A and student tickets sold by S, which expression represents the amount of money collected at the door from the ticket sales? Take a moment to pause this video at this time and try the problem on your own. So whenever you have the cost of an unknown variable, which is an adult ticket, and that's represented by A, and we have student ticket at a cost of $1.50 represented by S, we're going to write them as a product. And to express the amount of money collected, which is a total, and we know total represents sum. So we're going to write this as a sum of the product of these 2 components, adult ticket and its cost, as well as student ticket and its cost. So that is choice 4. Number 2, Mr. Turner bought X boxes of pencils. Each box holds 25 pencils. He left 3 boxes of pencils at home, and he took the rest to school. Which expression represents the total number of pencils he took to school? Pause this video at this time and attempt to do this problem on your own. Which expression represents the total number of pencils he took to school? Total number of pencils is the context of the problem. So Mr. Turner bought X boxes of pencils, and each box holds 25 pencils. So 25 times X. Now he left 3 boxes of pencils at home, and we need to know the total number of pencils. So we're going to have to adjust for that He left them at home, so that's minus 3 times the quantity of 25 pencils per box, and we have an expression represented as 25x minus 75, which is choice 4. Number 3, Marie currently has a collection of 58 stamps. If she buys S stamps each week for W weeks, which expression represents the total number of stamps she will have? Pause this video at this time and attempt to do the problem. So Marie currently has a collection of 58 stamps, is an amount that she already has. That's her starting amount. If she buys S stamps each week for W weeks, that's going to be S times W, which expression represents the total number of stamps she will have. Total number of stamps is going to be the sum. So the expression that represents this problem is 58 plus SW, or SW plus 58 is equivalent. Number 4, Tim ate 4 more cookies than Alice. Bob ate twice as many cookies as Tim. If X represents the number of cookies Alice ate, which expression represents the number of cookies Bob ate? Pause this video at this time and attempt to do the problem on your own. So Tim ate 4 more cookies than Alice. We don't know how many Alice ate, but Tim ate 4 more than she did. Bob ate twice as many cookies as Tim. So we know Tim ate 4 more than Alice, and Bob ate twice as many as Tim. And we need another boy here. So this could be Tim, and this can be Bob, and this can be Alice. If X represents the number of cookies Alice ate, which expression represents the number of cookies Bob ate? So Bob ate twice as many as Tim, which is double the amount of the quantity X plus 4, so that is choice 3. Okay, now we're going to represent equations, and in some cases we'll have to solve those equations. Number 5, the width of a rectangle is 3 less than twice the length x. If the area of the rectangle is 43 square feet, which equation can be used to find the length in feet? Pause this video at this time and attempt to do the problem on your own. Okay, so the width of a rectangle is 3 less than twice the length x. So the length is x, and the width is 3 less than twice the length x. This is where we're going to have to switch the positions. So because of the term less than, so we're going to have 2x minus 3. It's very important when we use the term less than that we switch the positions of the two quantities. So if we read further, it says the area of the rectangle is 43 square feet. So in a rectangle, area you should know is equal to length times width. We know that the area is 43 is equal to length, which is x, times the width. of the quantity 2x minus 3. So which equation can be used to find the length in feet? The equation we can use is the one most similar, choice 4. X times the quantity of 2x minus 3 is equal to 43. Number 6. At the beginning of her mathematics class, Mrs. Reno gives a warm-up problem. She says, I'm thinking of a number such that 6 less than the product of 7 and this number is 85. Which number is she thinking of? Make sure you set up an equation in order to solve for this number and pause the video at this time to attempt this problem. So Mrs. Reno is thinking of a number such that, so that means it's equal to 6 less than the product of 7 and this number is 85. Because of the term less than, we have to make sure that we switch the order. So we're going to have 7x minus 6 is equal to 85. And since x represents this number, the number we're solving for, we're going to solve this equation using inverse operations. The unknown number, the number that Mrs. Reno is thinking of, is 13. Choice 2. Number 7. If 5 times the measure of an angle is decreased by 30 degrees, the result is the same as when 2 times the measure of the angle is increased by 18 degrees. What is the measure of the angle? Take a moment to pause this video at this time and attempt the problem on your own. So 5 times the measure of an angle is decreased by 30 degrees. We can rewrite this in terms of 5 times the measure of an angle. That's the unknown quantity we can represent as x is decreased by minus 30 degrees. The result is, that's equal to the same as when 2 times the measure of the angle, unknown quantity of x, is increased by plus 18 degrees. So our equation is 5x minus 30 equal to 2 times x plus 18. You have a variable on either side of the equation, so we're going to use inverse operations to solve. There's one of 2 directions, and they're both correct that you can go in. I like my x's on the left-hand side. 2x is smaller than 5x, so I'm going to start with subtracting 2x from both sides. I get a difference of 3x, bring everything else down. That cancels out, and it's equal to that positive 18 if I drop that down. Now I have a 2-step equation, so I'm going to reverse the operation in order to isolate x. And then I divide out the 3. So the measure of the angle, which is the solution for x, is 16 degrees. Now we're going to enter the world of more in-depth setups and solutions with the open-ended problems. So we're going to set up our equations and solve. So number 8, the senior class is sponsoring a dance. The cost of a student disc jockey is $40 and tickets sell for $2 each. A, write an equation. It's going to represent a linear equation that represents the relationship between the number of tickets sold, T, and the profit from the dance, P. And part B, find how many tickets must be sold to break even. Pause this video at this time and attempt the problem on your own. So, referring to part A, writing the relationship between the number of tickets sold and the profit from the dance, we know that the cost of the student disc jockey is $40. Okay, so that is an outgoing cost that's constant and does not represent a profit. That's something that has to be paid, and this disc jockey is pretty cheap. So this disc jockey is going to have to be paid before you start making a profit. So the profit is going to equal $2 per ticket, and hopefully that's going to be more than $40. So minus the cost of $40. And how many tickets must be sold to break even? So we're going to take the $2 per ticket and set it equal to 40 divided by 2. And you have to sell at least 20 tickets in order to pay the disc jockey and break even. Number 9, Sarah's telephone service costs $21 per month plus 25 cents for each local call, and long-distance calls are extra. Last month, Sarah's bill was $36.64, and it included $6.14 in long-distance charges. How many local calls did she make? Pause this video at this time and attempt the problem on your own. So Sarah's telephone service costs $21 per month. That's a standard fixed cost. And 25 cents for each call. So that's going to be written as a product next to the unknown number of local calls that she makes. Long distance calls are extra. So last month her bill was $36.64. So that's going to be set equal to the sum of 21 plus 25 cents for each local call, but it included a $6.14 in long distance charge. So I'm going to add that to the $21. So $36.64 is equal to $27.14 plus the 25 cent times local calls. How many local calls did she make? That's the same thing as solving for X. So I'm going to solve this equation. So Sarah made 38 local calls last month. Number 10, Paul wants to go on a school trip that will cost $250. He is able to save $25 each week. Paul already has $30 set aside for the trip. What is the minimum number of full weeks for Paul to have enough money for the trip? Pause this video at this time and attempt to do the problem on your own. Okay, so the total cost of the school trip is $250. And he is able to save $25 each week. And he already has $30 set aside, so that's a fixed amount that he started out with. The minimum number of full weeks for Paul to have enough money for the trip is, I'm going to solve this equation. Divide out that 25. And 25 does not go into 220 nicely. You're going to get a decimal of 8.8. So the question is, what is the minimum number of full weeks? We can't have 0.8 weeks. Therefore, the minimum amount of full weeks Paul will have enough money is 9 weeks. So this is one of those problems where you have to check the reasonableness of the answer, and in this case we had to bump up. So Paul will have to save for a minimum of 9 weeks. We cannot use 8 weeks because you still have that 8/10 of a week and he would not have enough money. So he has to save for at least 9 weeks. Number 11, Jody's older brother is only 3 years less than twice Jody's age. If the sum of their ages is 30, then which of the following is the age of Jody's brother? Pause this video at this time and try the problem on your own. This type of problem is called an age problem. So we have Jody and Jody's older brother. So Jody's older brother is 3 years less than twice Jody's age. We don't know what Jody's age is, so we're going to let her be X. But we know that the older brother is only 3 years less than. So 3 years less than twice Jody. Because of the term less than, we have to switch the order. And we have 2x minus 3. Very important to switch when you see the term less than. If the sum of their ages is 30, so we're going to add these and get 3x minus 3 and set it equal to 30. Now I have a two-step equation to solve and answer the question, which of the following is the age of Jody's older brother? So we'll solve for x. That's Jody. Jody is 11, so her older brother is double that amount. Subtract. So 22 minus 3 is 19. Number 12, every month Omar buys pizzas to serve at a party for his friends. In May, he bought 3 more than twice the number of pizzas he bought in April. If Omar bought 15 pizzas in May, how many pizzas did he buy in April? Take a moment to pause this and try the problem on your own. In May, Omar bought 3 more than twice the number of pizzas he bought in April. So April comes before May. And the number of pizzas that he purchased in May is given in the context of April. We don't know how many he bought in April, but in May, he bought 3 more than twice the number in April. If Omar bought 15 pizzas in May, how many pizzas did he buy in April? So we're going to solve just this equation here. So since April is represented by X, the solution is that Omar bought 6 pizzas in April. This is the last problem that needed to be completed, so that concludes this lesson.